The transformation form is the most useful form for finding the vertex. For a quadratic function that's written in the transformation form, a times x minus h squared plus k, the vertex is the point with the coordinates h and k. So if I'm given this form, then all I need is the opposite of this number, because it's going to be a minus, so you're always going to switch it, and this number. And that gives me the coordinates of my vertex. Then since the y-intercept of a function is f of 0, that tells me that I can plug a 0 in anywhere I see an x up here. So f of 0 equals a times 0 minus h squared plus k. 0 minus h is just negative h. So I have a times negative h squared plus k. And that will give me my y-intercepts. Because I'm squaring that negative h, that's the same as ah squared plus k. Because anytime I square something, it's going to make it positive. So it doesn't matter whether that would be a negative that's getting squared or a positive getting squared. It gives you the same thing. I'm aware. Since the x-intercepts occur when y equals 0, then they are the solutions of the quadratic equation a times x minus h squared plus k. What does that mean? I don't quite know, but it sounded good. It means that if I set this equal to 0, I can now solve for x. And by doing so, just by having this vertex form, if I solve for x, now I know every time I can just plug these values into my new equation I find. So I'm going to subtract k over. It gives me a times x minus h squared equals negative k. Divide by a, it gives me x minus h squared equals negative k over a. Take the square root of both sides in order to get rid of my squared. It gives me x minus h equals, and when I take the square root of both sides, I have to take it to make it a plus and minus. So it's the square root of negative k over a, and then add the h, and I get h plus or minus the square root of negative k over a. So anytime I'm asked to find the x-intercepts and I have the vertex form, all I have to do is plug those numbers in here for h, k, and a. Okay, so for the function f of x equals 2 times x minus 3 squared minus 4, find the vertex and the x and y intercepts. Wusa. To find my, I'll let you write it down. So to find the vertex, this is the hard part, so I'll do this part and I'll let you figure everything else out on your own. To find the vertex, all I do is do the opposite sign of this, which makes it a positive 3, and then keep the sign on this. Opposite H, keep the K. So my vertex is 3, negative 4. Now you can figure out everything else on your own, and that's it. Just kidding. Now, on the last slide, we said that whenever we were trying to find the y-intercept, that we had used AH squared plus K, right? If I look at this form up here, this is A, so this is my form. So H is 3 and K is negative 4. So now I'm just plugging those in. A is 2, so it's 2 times 3 squared minus 4, or plus a negative 4, technically. 3 squared is 9, 2 times 9 is 18, so that's 18 minus 4, which is 14. That tells me my y-intercept is 14. Now to find my x-intercepts, I have to use the last piece that we did, which was move that up so I can see it, which was h plus and minus the square root of negative k over a. And so now I'm just plugging those numbers in. 3 plus or minus the square root of negative 4, makes that a positive 4, over 2. That gives me, what's 4 divided by 2? Good. So 3 plus or minus the square root of 2. Which means I have two answers. I don't know why this is a plus sign. It's supposed to be an equals. It means that I have 3 plus the square root of 2, which when I plug square root of 2 plus 3 in, it gives me squiggly equal sign, which means approximately 4.4, also known as the double tilde. And 3 minus the square root of 2, which is going to be double tilde, squiggly equals, approximately 1.6. Those are my two answers. In polynomial form, this is the most useful form for finding the y-intercept. Since the y-intercept is a function of f of 0, then the y-intercept is just c. Just think about it. If I plug a 0 in for x, everywhere I see an x, this would be a times 0 squared plus b times 0 plus c. 0 squared is 0, so a times 0 is 0. That's gone. A times 0 is 0. I'm just left with c. So then the x-intercepts are the solutions of the quadratic equation ax squared plus bx plus c equals 0, which can be solved either by factoring or by the quadratic formula. In general, the x-intercepts are negative b plus the square root of b squared minus 4ac all over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. Now you've seen the quadratic formula before. This is just splitting up the plus and minus aspects of it, but it is just the quadratic formula. So then to find the vertex of a quadratic function in polynomial form, compare the transformation form to the polynomial form. So first we would multiply and distribute the terms in the transformation form so that the coefficients can be compared. This is where we're going to pick up tomorrow, just for time's sake. So tomorrow I'm actually going to distribute this out. You can do it for tonight if you want. But I'm actually going to distribute out my x minus h squared. And then I'll multiply that by a. And then go from there. So tomorrow I'll really show you what we're going to do here. So, all right, that's it for today.